This is section 2.2, Variables and Formulas, part 2. Since the other one ended up being an hour long, we're going to move into triangles. The first example is similar to section 2.2, part B, number 16 through 18, where we're looking for the area. I've already gone ahead and given us the formula from the area of a triangle. You can find it on your formula sheet. And I'm going to go ahead and copy and paste this over here and show that we're going to substitute the base and the height. The base is 35, and I'm going to put this in parentheses again. The height is 6, and there we go. So I'm going to come over to my calculator and do 1/2, or I could type in 0.5, or I could use Microsoft Excel. 1/2, and I'm going to put times 6 times 35 gives me 105 equals 105. Now the units. Let's look at my formula. Base times height. The base was in yards, and I'm timesing the height, which is also yards. That's yards times yards, which is yard or yards squared. And I'm in a equation here, so I can't do my superscript. I'm going to come up to the design, do a script, and I want the superscript. And if I highlight it, it'll just give me the script up at the top. If I don't highlight it and press script, it'll give me both, and I'll have to arrow over and type in yards. Okay, there we go. 105 yards squared. Okay, the next part of triangles. They've given me two angles on this triangle. The first one is 35 degrees and the second is 86 degrees. We want to find out the angle, the measurement of the third angle. And here's an example where you can type out degree, or you can insert the symbol degree. It's up to you. Here I've used a way to notate angle. It's kind of like a sideways V, and it's just indicating the angle 1, and this is just my shorthand. Angle 1 plus angle 2 plus angle 3 on a triangle equal 180 degrees. So if I want to find this third angle, I need to add what I have and subtract it from 180. So I'm going to type in 180 subtract the sum of 35 plus 86. Or you could just come over and start typing in 180 and then subtract. You could subtract 35 and then subtract 86. It's up to you, however you want to do it, as long as you subtract those and you're left with 59 degrees. 59, oops, insert symbol, my degree sign. There we go. Okay, let's move to the next one, trapezoids. This is similar to section 2.2, part B, numbers 19 through 21, and part C, numbers 19 through 21. Again, our formulas are found here. Here's my trapezoid. The parameter for anything, you just add up all the sides. The area is 1/2 height, base plus base. So big B stands for the larger of the two bases. A trapezoid is kind of like a chopped off triangle. So the longer of the two bases is the capital B and the smaller is the small b. Okay, so I've already given us the formula. I'm going to come up here and copy and paste to save us time. And substitute in height using parentheses so that I know that this is the height being substituted in. And in this one you'll see that I have the large B over here. I'm adding, and I know that adding I can add back and forth, so it doesn't matter. I'm just going to add these in, and just because we'll go with the large one being first, I'll do 16 and 7. There we go. So 1/2 of 8 is 4. Oh, let's go ahead and do the parentheses first. 16 plus 7 gives me 23. Then I can times this by half of 8 is 4, which gives me 92. Now if you weren't comfortable with that, go ahead and type the whole thing into your calculator and it will do the order of operations. Or into Microsoft Excel. In Microsoft Excel, we would come here and do equal sign to make it calculate. 1/2, we have to put the time sign in, 8 times parenthesis, 16 plus 7, close parenthesis, enter. And oh, that was formatted as money, but we know that we're not working with money. It's 92. Okay, so 92, let's talk about the units. Here I have height times, well, let's talk about adding these first. I have 16 kilometers plus 7 kilometers. I'm just adding, so that's a straight up 23 kilometers. Now I have kilometers on the inside of here, but I'm multiplying it by the height, which is also kilometers. So even though it looks like I have three things here, these were added together and it's just a length, kilometers. So kilometers times the height's kilometers is squared. There we go. And highlight that to be the answer. Okay, the next one. Perimeter, I'm just going to add them all together. I don't even need to follow the formula here. So I'm going to do 10 plus 15 plus 13 plus 9. Perimeter is just like fencing, all the length of everything on the outside. And to speed things up, we're going to do 10 plus 15 plus 13 plus 9. There we go, 47, and because it's only length, I just need centimeters, and I'm done. Okay, the next section is rectangular solids. This is similar to section 2.2, part B, numbers 22 to 24. I was given the length, the width, and the height, and we want to find surface area. I've already given us the formula found on the formula sheet or in your book. And I'm going to do my work over here. So I'm just going to copy and paste that in and start substituting. Okay, the length was given as 6. The width was given as 12. Arrow over. The height is given as 3. The width was given as 12. Arrow over. Substitute in the L for 6. And the height is 3. There we go. So if I were doing this by hand, I would be multiplying these three numbers, and these three numbers, and then adding them together. To speed us up, I'm going to go ahead and just type this in. 2 times 6 times 12, add 2 times 3 times 12, plus 2 times 6 times 3, 252. Some of you are thinking that since I showed you how to do the order of operations that your calculator will do it, that you're just good to go. You do need to know the order of operations because sometimes typing it into your calculator differently, you can double check that maybe you typed something in wrong. And I could do the exact same thing in Microsoft Excel by pressing equals and typing in all of the numbers, 2 times 6 and so forth. I'm not going to go any further though. Let's talk about the units. Here I have length times width. That's kilometers times kilometers. That's kilometers squared. Here I have height times width, which is kilometers times kilometers, or kilometers squared. And again, length times height, which is kilometers times kilometers, which is kilometers squared. That means that each of these is kilometers squared. And that means they're like terms, and I can go ahead and add them. It does not mean that I have kilometers squared, kilometers squared, kilometers squared to get kilometers to the 6th. This means I'm just adding a bunch of kilometers squared, which is good because then that means that I could add those and the terms are like terms and the dimensions add up and the whole thing is just kilometers squared. And I'm going to highlight that as the answer. Okay, the next one's asking for volume. The volume of a rectangular solid. This is like a box or a cube, and I think most of you are okay with it. In fact, many things are talk about the dimensions of length times width times height. So I'm thinking you might not even need to go on your sheet to look at this formula. Let's do length, which is 11, times width is 5, times height is 8. Oops. Multiply that together. Bring it up here. 11 times 40, which should give me 440. There we go. 440. A really fun trick with multiplying 11 is that you take the two numbers and you split them up. So if it's times by a double digit, so if it's 11 times 40, you take the 4 and the 0 and you separate them, and then you add, and whatever that addition equals, you put it in the middle. So if it was 11 times 19, you'd do 1 and then 9, oh, sorry, let's do something that you don't have to carry. So 1 and a 6, so 11 times 16, you add those and you put a 7 in the middle. So 11 times 16 is 176. It's one of my favorite multiplication ones. Okay, 440, and now let's talk about the dimensions. I have length times width times height. That means I have inches times inches times inches, which gives me inches cubed. And most of you are thinking volume is cubed, so that one's perfect. Okay, let's move on to simplifying the next part. These are just a couple of equations where we need to simplify it as far down as we can. Okay, using the order of operations. I can't type these ones into my calculator, so I'm going to have to work out, please excuse my dear Aunt Sally. Because I cannot add or subtract the d and the 8, I can't do anything, so I have to use the distributive property. So I'm going to multiply the 7 into the d, which gives me 7d. Then I need to multiply the 7 into the negative 8, or minus 8, so I'm going to minus, which gives me 56. Now, the 21 is on the outside. It's not being added or subtracted or multiplied to anything. It's just hanging out there in the add 21. Now I look at it and see, can I combine anything? There's only one d, so that term is just 7d. However, I can add and subtract my negative 56 plus 21. Negative 56 plus 21, negative 35, or minus 35. And that's as far as I can go. I can't combine anything else. Okay, let's go to the next one. Again, I can't add inside the parentheses, so I need to do the distributive. The 6xy isn't a part of the distributive, so he stays out front. Then I have 5x times 3y. That means I can multiply 5 times 3, which is 15, and the x and the y. Now I need to multiply the 5x into the next one, 5x into 3y, 5x into 10m. So 5 times 10 is 50, so I need my plus sign. Then I have the x and the m. Okay, now I look through and see, can I combine anything? In this one, I can. I combine the xy with the term with the xy. Those are called like terms. So I get 6 plus 15, which is 21, xy. And there's nothing else with the xm, so it's just 50, xm. Those are two, they are not like terms, so I'm done. Okay, let's move to the next one. going to tab over to do some of my work. In this one, I cannot combine inside the parentheses. So again, I'm going to do the distributive property. So out in front, I have 5x squared. That's not a part of the distributive property. Here, I have minus 3x. I like to look at minus signs and group it together with the sign that it or with the number that it follows. Some teachers also teach you add the negative so that it groups it in. If you're more comfortable with that, go ahead and put add negative 3. So I'm multiplying in negative 3x to 3x or 2x squared. So I have negative 3 times 2, which I can put is plus a negative 6, or I can put minus 6. It's up to you, whichever one you prefer and feel most comfortable with. Then x, I have x times x squared. So that's x squared means I have x times x. I'm adding in one more, well not adding, I'm multiplying in one more x. So that's 3 x's together, which gives me an exponent of 3, x cubed. Now I'm multiplying in my negative 3x to my negative 6x. Negative 3 and negative 6 give me a positive 18. Now I look at my x's. I have 1x times 1x. So that's 2 x's, or x squared. Now I have this last little part, 17x cubed. That's not inside. It has nothing to do with the distributive property. Okay, now I look at it and see, can I combine anything to simplify it further? In this case, I can. I have 5x squared and 18x squared. Those are like terms. 5 plus 18 gives me 23. 23, oops, I don't want to be in a superscript. There we go, 23x squared. Click out of my superscript. And now I look at the other one. I have a term with x cubed and another with x cubed. That means I can combine these as well. Negative 6 plus 17 gives me, oops, out of the superscript, gives me a positive 11, and then my x is x cubed. And I cannot combine the x squared and the x cubed because those are not like terms. This one only has 2 x's, whereas this one has 3, so I'm done, and that's the answer. Okay, let's move to the last example. Here, again, I cannot add inside the parentheses the z and the 3g. They can't add. They are not like terms. So I'm going to have to use my distributive property once again. Here, you can leave it as negative 4 or minus 4 and think of it as being negative, or you can go ahead and what some teachers like to call is add a negative so that you see that the negative is still attached to the 4. Okay, and we're going to use the distributive property, negative 4 times z. So here the 9 isn't being affected, nor is the 8g being affected. Negative 4 times z, I can write plus negative, click out of that, 4z, or you can write minus 4z. Either way, as long as the negative sign or the minus sign is in front of the 4. Now I have negative 4 times, doing the distributive property, we did it times the z, now I need to do negative 4 times 3g, which gives me plus a negative, or you can write minus. 4 times 3 is 12, and g. There we go. Okay, can I combine anything? 9 is the only one that doesn't have any variable with it, so he can't be combined. So I'm going to leave him 9. The g's, however, the 8g has another one it can combine with, which is this negative 12g. Positive 8 and negative 12 give me a negative, so I'm going to put plus negative 4g. Oops, click out of there. 4g. Or if you don't like that, you can, instead of doing that, just write minus 4g. It's up to you, whatever you prefer and feel comfortable with. Okay, so now I've combined the g's and the 4z. It's all by itself. I can't combine it with anything, so I can put plus negative 4z, or if you want, you can just leave it minus, whatever you feel comfortable with. I'm going to do a superscript for the negative so that it looks like a negative, and 4z. Oops, I did it again. Unclick from the superscript, 4z. There we go. Nothing else can combine there. So we've added all of the like terms, and it's simplified as far as it can go. All right, that was the second part of Lesson 5, Section 2.2, Variables and Formulas. Feel free to pause, skip, forward, rewind, or rewatch different parts that you may need.